Introduction.
Hi Renu, what are you doing? Hey Priya, please come. I'm making some drawings. Oh great! Can I help you? Yes please. Can you make similar trees? Yes, I can make trees. But would you find out if these are similar or not? There are certain things which you should check while checking similarities. Do you want to know? Yes, why not? Please tell. Okay, come. I will tell you.
Objectives. At the end of this lesson, you'll be able to define similar figures, learn about similarity of triangles, understand the criteria for similarity of triangles. Similar figures. Congruent figures. In order to be congruent, two figures must be of the same size and same shape. Similar figures. Similar figures must be of the same shape, but their sizes may be different. This is the symbol that means similar. When you have a photograph enlarged, you make a similar photograph. A photograph can also be shrunk to produce a slide. So, similar figures are two figures that are the same shape and whose sides are proportional. Similar figures 2. Two polygons of the same number of sides are similar if 1. Their corresponding angles are equal and 2. Their corresponding sides are in the same ratio or proportion. The same ratio of the corresponding sides is called the scale factor for the polygons. All congruent figures are similar, but the similar figures need not be congruent. Example. Consider the following squares. Clearly, AB upon PQ equals BC upon QR, which equals CD upon RS, equals DA upon SP, which is equal to 2. Also, angle A equals angle P, angle B equals angle Q, angle C equals angle R, angle D equals angle S. Thus, the squares are similar figures as their corresponding sides are proportional and their corresponding angles are equal. Similarity of triangles. If the angle of one triangle are equal to the angles of another triangle, then the triangles are said to be equiangular. Equiangular triangles have the same shape but may have different sizes. So, equiangular triangles are also called similar triangles. Or we can say that if two triangles are similar, then they are equiangular, the corresponding sides are in the same ratio, the angle included between any two sides of one triangle is equal to the angle included between the corresponding sides of the other triangle. The ratio of any two corresponding sides in two equiangular triangles is always the same. Basic proportionality theorem. Basic proportionality theorem or Thales theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Given a triangle ABC, D and E are any two points on AB and AC respectively such that DE is parallel to BC. To prove AD upon DB equals AE upon EC. Construction. Join BE and CD. From E, draw EF perpendicular AB. Prove. Since DE parallel to BC, therefore area of triangle BDE equals area of triangle CDE. Mark it as 1. Since triangles on same base and between the same parallels are equal in area, since area of a triangle is equal to 1 by 2 into base into altitude, or area of triangle ADE upon area of triangle BDE is equal to AD upon BD, mark it as 2. Similarly, area of triangle ADE upon area of triangle CDE, which is AE upon C, mark it as 3. From 2 and 3 we have AD upon BD equals AE upon EC, hence proved. The converse of this theorem is also true, which says that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Example of similarity of triangles. In the given figure, DE is parallel to AC and DF is parallel to AE. Prove that BF upon FE equals BE upon EC. Solution. In triangle ABC, DE is parallel to AC. Therefore, BD upon DA equals BE upon EC by basic proportionality theorem. Mark it as 1. In triangle BAE, DF is parallel to AE. Therefore, BD upon DA equals BF upon FE by basic proportionality theorem. Mark it as 2. Now, from first and second, we obtain BE upon EC equals BF upon FE. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that AO upon BO equals CO upon DO. Draw a line EF through point O such that EF is parallel to CD. In triangle ADC, EO is parallel to CD. By using basic proportionality theorem, we obtain AE upon ED equals AO upon OC. Mark it as 1. In triangle ABD, OE is parallel to AB. So, by using basic proportionality theorem, we obtain ED upon AE equals OD upon BO, which implies AE upon ED equals BO upon OD. Mark it as 2. From equations 1 and 2, we obtain AO upon OC equals BO upon OD, which implies AO upon BO equals OC upon OD. Criteria for similarity of triangles. There are 3 main criteria for similarity of triangles. 1. AAA or AA. 2. SSS. 3. SAS. If in two triangles the corresponding angles are equal, then their corresponding sides are proportional, that is, in the same ratio, and hence the triangles are similar. In two triangles, ABC and DEF are similar if 1. Angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, and 2. AB upon DE equals BC upon EF, which equals CA upon FD. In such a case, we write triangle ABC is similar to triangle DEF. Criteria for similarity of triangles. 2. SSS similarity. If the corresponding sides of two triangles are proportional, then the two triangles are similar. Two triangles ABC and DEF such that AB upon DE is equal to BC upon EF, which equals CA upon FD. Then the two triangles are similar by SSS similarity. AAA similarity. If two triangles are equiangular, all three angles are equal to each other, then they are similar. AA similarity. If two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. SAS similarity. If in two triangles, one pair of corresponding sides are proportional and the included angles are equal, then the two triangles are similar. In triangle ABC and DEF, angle A is equal to angle D and AB upon DE equals BC upon EF, which equals CA upon FD. Then the two triangles ABC and DEF are similar by SAS. Example. In the following figure, triangle ODC is similar to triangle OBA. Angle BOC is equal to 125 degree and CDO is equal to 70 degree. Find angle DOC, angle DCO and angle OAB. Solution. DOB is a straight line. Therefore, angle DOC plus angle COB equals 180 degree, which implies angle DOC is equal to 180 degree minus 125 degree, which equals 55 degree. In triangle DOC, angle DCO plus angle CDO plus angle DOC equals 180 degree. Sum of these measures of the angles of a triangle is 180 degree, which implies angle DCO plus 70 degree plus 55 degree, which equals 180 degree, which implies angle DCO equals 55 degree. It is given that triangle ODC is similar to triangle OBA. Therefore, angle OAB equals angle OCD. Corresponding angles are equal in similar triangles, which implies angle OAB equals 55 degree. In the following figure, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. Solution. It is given that triangle ABE is congruent to triangle ACD. Therefore, AB equals AC by CPCT, mark it as 1, and AD equals AE by CPCT, mark it as 2. In triangle ADE and triangle ABC, AD upon AB equals AE upon AC, dividing equation 2 by 1. Angle A is equal to angle A, common angle. Therefore, triangle ADE is similar to triangle ABC by SAS similarity criterion. D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC. Show that CA square equals CB into CD. Solution. In triangle ADC and triangle BAC, angle ADC equals BAC is given. Angle ACD equals angle BCA, which is common angle. Therefore, triangle ADC is similar to triangle BAC by AA similarity criterion. We know that corresponding sides of similar triangles are in proportion. Therefore, CA upon CB equals CD upon CA, which implies CA square equals CB into CD. Did you know? A triangle is a three-sided polygon that has three vertices or corners. Triangles are commonly used in construction to create supporting structures and figure heavily in artworks. Students learn all about triangles in their mathematics classes and trigonometry. Triangle geometry is the study of the properties of triangles, including associated triangle centers, triangle lines, central circles, triangle cubics, and many others. These geometric objects often have remarkable properties with respect to the triangle. Summary. Let us summarize what we have learned. Two figures having the same shape but not necessarily the same size are called similar figures. All the congruent figures are similar, but the converse is not true. Two polygons of the same number of sides are similar if 1. Their corresponding angles are equal, and 2. Their corresponding sides are in the same ratio, that is, proportion. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. If in two triangles, corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar by AAA similarity criterion. If in two triangles, two angles of one triangle are respectively equal to the two angles of the other triangle, then the two triangles are similar, or AA similarity criterion. If in two triangles, corresponding sides are in the same ratio, then their corresponding angles are equal, and hence the triangles are similar, SSS similarity criterion. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are in the same ratio, proportional, then the triangles are similar, SAS similarity criterion.